How big is the universe? If you step outside on a clear night and look up, it feels like the universe is right there in a black canvas sprinkled with dots. And you might think, I can see stars, and so surely we've got a pretty good idea of how far this all goes, right? Not quite. The truth is, even our best telescopes can't give us a complete picture of the universe's full size. We have a limit, a literal horizon, beyond which light has never reached us. Everything past that horizon might as well be invisible because in the 13.8 billion years since the Big Bang, light from those regions simply hasn't had time to get here. But here's the twist. Even within that observable part, the numbers are far beyond human intuition. When scientists talk about the universe's size, they use units like light years. And one light year is about 9.46 trillion kilometers. So how do we make sense of something this vast? That's the problem. Like, our brains didn't evolve to handle cosmic scales. We evolved to throw rocks, not measure galaxies. Let's put this in perspective. If the sun, the bright object you see in the daytime sky, is about 150 million kilometers away from Earth, light from the sun takes about 8 minutes and 20 seconds to reach us. That's basically nothing in cosmic terms. And the next nearest star, Proxima Centauri, is 4.24 light years away. That means if the sun were a coin in your hand, Proxima Centauri would be another coin sitting roughly Paris to Moscow apart, and that's just our closest neighbor. Now, zoom out. The Milky Way, our home galaxy, contains around 100 to 400 billion stars. From edge to edge, it's about 100,000 light years wide. If the Milky Way were shrunk to the size of a dinner plate, the Andromeda Galaxy, our nearest major neighbor, would be another dinner plate sitting about 2 meters away. But even that is small compared to the bigger picture. The observable universe is a sphere centered on Earth with a radius of about 46.5 billion light years. That's because while the universe is 13.8 billion years old, space itself has been expanding, stretching those distances over time. Here's where it gets uncomfortable. We can only see objects whose light has reached us since the Big Bang. That edge isn't the edge of the universe, it's just the edge of what we can observe. Beyond that, or there could be hundreds of times more space or infinite. We simply don't know. And if that's not enough to shake your sense of scale, consider this case study from the Hubble Deep Field Project. In 1995, NASA pointed the Hubble Space Telescope at a tiny, seemingly empty patch of sky about the size of a grain of sand held at arm's length. They left the shutter open for 10 days. When they processed the image, they found thousands of galaxies in that tiny patch. Multiply that across the entire sky, and you get an estimated 2 trillion galaxies in the observable universe. That's 2 trillion star cities, each with billions of suns. And remember, that's just the part we can see. So how big is the universe, really? Let's break it into 2 parts. First part, the observable universe, the numbers we know, radius, about 46.5 billion light years diameter, about 93 billion light years across. Estimated galaxies around 2 trillion. Estimated stars about 1 times 10 to the 24 stars, even that's a 1, followed by 24 zeros. If we imagine the sun is the size of a peppercorn, Earth would be a grain of sand about 2.5 meters away, and the observable universe would be a sphere over 7 million kilometers in diameter on that same scale. How we measure it. Scientists use cosmic background radiation, the faint afterglow of the Big Bang, as a reference point. By studying its temperature and tiny fluctuations, they can calculate distances and expansion rates. The Planck satellite and other observatories have given us precise measurements of the universe's age and expansion speed, about 73 kilometers per second per megaparsec, according to some measurements. This expansion is why the observable universe is so much larger than 13.8 billion light years. As light traveled toward us, space itself stretched, carrying galaxies farther away. Second part, the entire universe and the numbers we suspect. This is where things get speculative, but still grounded in scientific reasoning. Based on inflation theory, the universe underwent a burst of exponential expansion in the first fraction of a second after the Big Bang. That expansion could mean the universe is at least hundreds of times larger than what we can see. Some models even allow for an infinite universe. Here's an analogy. Imagine you're in a small room with fog and you can only see a sphere of space around you because the rest is too hazy. That doesn't mean the room ends there. It just means that's as far as your eyes can reach. Cosmic microwave background mapping. The Planck mission mapped the cosmic microwave background with high precision. The pattern suggests the universe is spatially flat within a 0.4% margin of error. A flat universe could be infinite, or at least so large that the curvature is undetectable from our vantage point. If that's true, then the 93 billion light year observable sphere is just a tiny part of a potentially endless expanse. Let's try to make this feel real without overcomplicating it. Stars, Edurs is grains of sand. Astronomers estimate there are more stars in the observable universe than grains of sand on all the beaches on Earth. Travel time. Even if you could travel at the speed of light, it would take you 46.5 billion years to reach the edge of the observable universe. And by the time you got there, the universe would have expanded even more. Galaxy scale, if the Milky Way were a coin, the observable universe would be about the size of North America. So how big is it? Observable. 93 billion light years across, 2 trillion galaxies, entire universe, potentially infinite, but at least hundreds of times larger than the observable part. We're living inside a sphere of data limited by the speed of light in the age of the cosmos, but beyond that, the universe could go on forever. What this means for us. This isn't just trivia, it's a reminder of our position in the cosmic story. Every human experience, every moment in history has taken place on a tiny rock in a galaxy that is one among trillions. Knowing the universe's size isn't about making us feel small. It's about showing us how much is left to discover. Just as the Hubble Deep Field revealed galaxies in a spot that looked empty, the next breakthroughs could come from looking deeper into what we think we already understand. So the next time you look up, remember, you're not just seeing stars, you're looking at the edge of the knowable, standing on the shoreline of an ocean without end.